We're live. Hi, Jake. Welcome to Venture with Grace.
Good morning, and thanks so much for having me, Grace.
Okay, to start the show, I would love for the audience to get to know you a little bit more. So, you started your career in engineering, and then you were the first business hire at Cloudera, and prior to that, and then after that, you ran product at Splunk, and you entered venture career at Accel, and then now you're part of Wing. Why don't we start with what are some core lessons that you've learned early on in your career that you kind of took into investing today?
Yeah, no, it's a great question. Early on in my career, it was all about engineering and product, and that's really where I focused on honing my skills. Can we build the right product experience to meet a user need? As I thought about the transition to venture, one of the realizations that I had is that it's just unfortunate, but the best product, the best technology, it doesn't always win. There's a lot more that goes into a company than just building something, or build it and then they will come, right? And the go-to-market strategy, whether that's PLG, whether that's partnerships, the efficiency of these strategies just sort of matters so much in terms of the ultimate success and value of these companies. And that's not where the first 3 or 4 years of my career were focused. And as I sort of broadened and spent more and more time thinking about the business, that's increasingly been an area of focus for me.
For sure. I like what you said about just having a good technology is not enough. You have to focus on, different part of the business to actually make a business win. And I wonder, so maybe we could start with, how, first of all, I'm just in genuine curiosity on I feel like you're a very technical person while I was listening to these other podcasts that you're on. How do you actually study a technical space?
How do I study a technical space? Well, I mean, it's some of the most fun things to do when you meet someone that comes in and they have a PhD from some university. They're sort of well published, and if I'm doing my job right, I'm meeting someone that's sort of far smarter than me and knows infinitely more about whatever the subdomain of interest is. And I do have a degree in computer science, and so I really like to understand things from a technical perspective and from a product perspective first, and I can do some of that myself. At some point, we call in experts to further validate what's going on. But the real truth of it is, after it sort of passes that initial smell test, most startups don't fail because the technology fails to deliver on the initial promise that was stated. And so it's very important to validate that. And we spend a lot of time on that. But it's actually, I wouldn't say easy, but it's something you can do with a reasonable degree of certainty. The far trickier thing, and the reason why startups fail, is because building that thing turns out to not deliver as much value as you initially thought. That thing turns out to be really hard to, again, bring to market efficiently. And far more technology companies and startups, I think, sort of struggle and fail for that reason than hey, they just can't build it. There's a certain type of company that's taking true, it's the difference between R&D, right? There's some companies that are in R, and they actually have to prove some technical feasibility of something that's never been done before. And some of that belongs in the research world, and DARPA should fund that. There's an amount of that I think is venture appropriate research risk. And then far more often, the companies are in the development. Can we just build it? And it's a lot more knowable once you get into the D, or development.
Totally. Okay, so let's talk about edge. So why don't we start with what is edge computing? And so obviously I feel a lot of people are not I myself, before I talk about edge with other people, I did not know that edge means kind of your device connect to other device. And maybe you could give the audience a little bit of rundown, what is edge computing, and then we can go from there.
Sure. I think edge is one of these words that doesn't have a great definition, and sort of your mileage will vary. I think the simplest definition is just sort of defining what it's not. We may spend time together on this this conversation talking about what's going on in the data center, the rise of NVIDIA and GPUs and these huge clusters that are used for training and now for inference. That's not the edge. Like, that's the data center. Everything else, in my opinion, is the edge. There's all sort of shades of gray. The first thing that's not the edge, it might be some of these really sort of pop locations, these things that are points of presence that are closer to end users. Don't need to spend that much time on that. Computers, like whether it's your server, whether it's your laptop, this is an edge device. And I think there's a lot of interesting opportunities as we think about generative AI in terms of what models are going to run where, and just sort of what are the cost and latency characteristics of a model, and what does it mean for a business. And so if you want to serve 1 million users for free, and your model is big and expensive and runs in the cloud, you need to have a certain business model that supports it. If your model can be shipped to someone's laptop and run locally, it's sort of free in some ways, or close to free for you to deliver in this way. So it unlocks a whole new type of potential business model. Then you get to smaller devices, whether it's phones or less powerful devices that are Raspberry Pis, and then it sort of veers off into other directions, whether it's sort of self-driving cars, robots, things that sort of belong in the OT sort of manufacturing, plant space, drones, all those sorts of things sort of fall into the broader definition of edge, in my opinion.
Oh, wow. So like, I have a question in that. So like, what are some like opportunities that you find really interesting in the edge computing space? And since like, as we just talked about, like literally everything is edge. Yesterday I went to, so I'm currently at CS, and I went to one of the Samsung showroom. There is, I guess, edge flowers. So basically it's like you control like there's like a machine for flowers. And then basically like you put flowers in there, and then you can monitor the flowers growth by using your phone. So I assume that's like edge device. And then, or let's say like people do a lot of like the glucose monitor. You put something on your arm, and then the app will tell you what to make. And then the fridge can show you there's like 5 broccoli in your fridge and then how to make them or something. So okay, so those are like the use case for like a normal human being, but what does the products look like from a software world?
Yeah, so a lot of them, first of all, a lot of them I'd say touch different modalities. A lot of the way that sort of the intersection of vision and AI is going to impact the world is on the edge, whether it's something as like self-driving cars, whether it's sort of these visual inspection tasks, whether it's automation within a factory or a warehouse. These are all edge AI use cases. I think we're starting to witness the rise of use cases that involve modalities like audio, where you're going to start to have conversations. And again, some of it might get shipped to the cloud, some of it might not. But you're starting to have these communications with the device on the edge. And in the future, you'll be able to, ask your electronic device for help or something if you get stuck. So these are just a few of the applications and use cases. The thing that makes edge exciting is it has a lot of similarities with the data center, but it also has a lot of differences. And those differences lend themselves to create opportunities. And so you could say NVIDIA has a really strong position within data centers for training AI workloads. I think it has a reasonably strong position on the edge, but it's different. Like there's a different class of competitors emerging, and we see opportunity there. We've backed a semiconductor in the edge AI space to help with AI and generative AI workloads, because it's just very different thinking about how to build a chip that doesn't have a plug or has to fit in the sort of heat dissipation sort of profile of a teeny tiny device. And so there's opportunities really low within the stack. There's opportunities in terms of the models themselves, really small models that can sit on the edge, that can do generic things and be a voice assistant, that'll one day do translation, all those sorts of things. And there's reasons why sometimes those things have to be only on the edge and maybe sometimes not. It's really, really hard to deploy models on the edge. And so, a lot of the data center sort of compute stuff, you have to orchestrate it, but it's more like how much it's going to cost. The thought of like updating a model that's in like an app that's like, on iOS It just has so much more complexity to it. Or if you think about the Android ecosystem, how many different phones are there? How many different pieces of hardware? How do you make sure it works in all those? How do you deploy it? How do you know when you use the sort of CPU, the general sort of processing engine on these devices, or whether it's called an NPU or a DSP, the more specialized chips, and like when to take advantage of each of these, or the drivers even working, it just becomes very complicated. So there's this whole extra ecosystem of tooling and technology to support those. And so we're excited about all of those layers in the stack on the edge.
Okay, so let's break down the stacks, and then maybe we could talk about the company that you have invested in that you mentioned it's like a semiconductor company in the edge space. Can you share a little bit more about, like, how did you identify the space, and what are something interesting happening there, and how do you pick this company, basically?
Sure. So I work at a company called SiMa.ai. They're somewhere at CES, so you could probably go find them. And there's a lot of need for compute at the edge, and the thing that I observed is that there's just not enough power at the edge for the current generation of chips. And so that basically translates, like, if you want a car that's not going to run out of battery quickly, or you want a drone that can stay in the sky, or you want a robot that doesn't need to constantly recharge, you need to really unlock a lot more sort of compute efficiency. And there's really sort of technical representations of this in terms of like TOPS and all these things that like most people like who aren't like really working deeply with a chip would think about. The industry has started to converge on something I call like frames per second per watt. So in a computer vision use case, you basically sort of think about like how many images can you look at for whatever unit of power. And the opportunity that presented itself is like, what if you could take an order of magnitude leap forward from a frames per second per watt perspective? What would you have to do? You'd have to sort of like rethink how the entire chip is made. There's a lot of assumptions that you'd make if you were building something for a data center that you just have to throw out to create the type of efficiency that could unlock this type of energy savings. And so I came across a gentleman named Krishna Rangasai, who had started this company. He had been in the chip industry for many years. He worked at an FPGA company called Xilinx, where he held all sorts of ranks, and he assembled just this really unique sort of multidisciplinary chip team to tackle this problem. He'd taped out, his teams had taped out dozens and dozens of chips over the lifetime, so they had a lot of the right experience, and they'd assembled this unique blend of talent who deeply understood a lot of the traditional semiconductor things and a lot of the AI things. And one of the most interesting things about this company is that basically to create energy efficiency, you have to put as few things into the chip as possible. And the way I would explain that to lay people is that as soon as you etch something, as soon as you design something where electrons are going to flow, all you know is it's going to consume power. And so one of the really high level precepts is keep the chip as simple as you can and put as much smarts into the software as you can. And this means that there's a lot of work that has to go into the various different software layers, like the compiler, to help make this possible. And again, the edge is so hard to figure out what the parameters of these systems are. And so you even need to go further up the stack. You need to go, way up the stack to that end user who's building the application. And how do you make it easy for them to create an AI-powered application on the edge without understanding or needing to know at all times all these technical details? And that's actually, one of the most beautiful things that NVIDIA has done. And, part of their dominance is sort of CUDA and the software ecosystem. And so I'd say, in some ways, the success of NVIDIA at this point is even more driven by their software than their hardware. It's the whole ecosystem together. And the thing that NVIDIA's competitors don't really have in the data center is the same level of software and frameworks that NVIDIA has. And the opportunity on the edge is to do something even better and even different. But it's it's a whole lot of it's both hardware and a surprising amount of software to create this accessible end user experience.
Can I ask? Okay, so what is like, I mean, this question may sounds really dumb for like a super technical person, but okay, what is NVIDIA's like business play here? Just because I hear people because I like hear people that saying NVIDIA is trying to like, you know, like replace like a AWS effect, or like basically building out their own ecosystem of partners. But on the other hand, there is since like I feel like maybe if you could break down like what are like the core revenue generation area from NVIDIA, and then
Sure.
is it like kind of why is it like unshakable, or like why is it like hard to be disrupted, and then how, for example, your investment in this other company
Sure.
like kind of
Sure. So NVIDIA is a phenomenal company. It's one of the most valuable companies, and so going against it head on, I think is very challenging. And the vast majority of NVIDIA's revenue comes from shipping GPUs that are used in data centers. There's a big sort of like gaming graphics card business, maybe that's sort of like on laptop land. And there's smaller businesses that touch automotive and edge use cases. They're just smaller and probably as a result get less attention and focus from NVIDIA, not none. You made this comment about like, are they going to back their way into a GPU cloud of some kind? I don't know, but I think the phenomenon, like I have no non-public information to share. I think the phenomenon that's going on is that they have something that everyone else wants. And if they basically just gave all the GPUs, and I think like 3 to 5 companies could eat up all of their supply if they really allowed. But what that would do would give a lot of these few vendors, whether a cloud vendor or something else, a lot of control in this ecosystem, whether it's control of who gets access to them, whether it's sort of pricing power, all different sorts of things. And so if you're in NVIDIA's shoes, what you don't want are very, very large companies having lots of control. And so you want to sort of peanut butter those resources a little bit more broadly. And right now, some companies are so supply constrained that they have a lot of leverage to do that. So they've supported the rise of a lot of these GPU cloud providers, to create more and more alternatives. And the question ultimately becomes the one that you asked, like, could they just sort of back their way into building their own GPU cloud or building their own sort of broader infrastructure as a service cloud? It's possible. I think there's a lot of things that NVIDIA knows how to do well already, and there's some things they can learn, and we'll see. We'll see. But I think it's sort of motivated from wanting to sort of balance the power ecosystem, balance that power dynamic with these very large players not be beholden to a few. That's why they're thinking about those sorts of things. Why did I invest in SiMa.ai? Really because I saw an opportunity to sort of take risks and do things on the edge that I think would be a little bit harder for a large incumbent to do, because they have to think about their whole sort of suite of products. They have a huge history and a huge skill base and a huge code base. And a lot of the things you need to do on the edge, I think, are just different enough that there's a different competitive opportunity and a different dynamic to just be more different and succeed. Where the bar for fighting within the bowels of the data center right now, I think is just much higher at present.
So why, I guess, like, how do you think about like their client acquisition strategy? So I'm currently on their website. So I wonder, how do you who are they selling to? And then why is it going to be like $1 billion business here?
Yeah, for sure. I mean, so they're selling to people that have edge use cases. And this could be, again, people that make cars, that make drones, that make robots, that are on manufacturing floors. And a lot of their initial customers are companies that want things for which there are no other solutions. There's just sort of no way to get the power efficiency or the performance in any other way. And so they have to deliver on that sort of technical performance metric, and they have to deliver on ease of use. They have to make it really accessible for people to build these applications. Again, on the edge, I would sort of almost say it's far harder to build these applications today. And depending on the type of business you're working with, the amount of talent available is sometimes less. The amount of talent in a manufacturing production facility versus a big tech giant to work on AI, right? There's just sort of different amounts of technical teams sort of in some of these businesses. And so if you can help them unlock this value on the edge, I think there's no limit to the number of use cases you can serve. You have to go sort of one by one. It's not like in a data center where 3 or 4 companies can make are your entire business with the cloud vendors. You're going to need dozens and hundreds of vendors. But a lot of these things, as they go into production, they're millions or tens of millions of dollars of revenue opportunity per customer.
Is the things that they sell are actually like a chip, or like is this like an actual software? Because
both.
Yeah, I'm just trying to. Okay.
Both. Yeah. I mean, you really need both. You monetize in different ways, but it has to be usable, and you can. We don't need to go into the details of exactly how this particular company prices, but it has to be this whole end-to-end experience that's easy to use, right? And it needs all those software layers to fulfill that promise. And so I sort of say I want it like 10x more power efficient and 10x easier to use. 10x easier to use might be a little hard.
So for the chip that they're, I guess like what would come first? So like, for example, for a company like this, like, do they have to, like, since you mentioned that's like 2 business model, like one part is like selling the chip itself, and then the other part is the software, assuming the software come with the chips. But let's say if I'm like a Samsung or something, and then they're trying to sell it to me, and how would we kind of like work together? Is that like we kind of like talk about, my use case here's like, I want to connect, the chip into my smart fridge, and then they develop a solution for the smart fridge? Or like, do they have already one set of solutions? Because I'm on their website, it's automotive, healthcare.
So a lot of it winds up being sort of like problem class, or you even could get as technical as model class. Like, what's the thing you want to do? Like, do you have like are you trying to run like ImageNet? Do you have like a visual classification task? Do you have an audio understanding task? What's the nature of that? And, this company's already built out like a reference architecture for a lot of these things. And for a really sophisticated group, they could be like, hey, just try it. And you could try it and emulate it in the cloud. You could buy sort of a dev kit and try it. Many different ways to try it. Or you could say, hey, I want a little bit more help, and engage more deeply with the team. And in this case, like, there's a few areas where we're thinking about, hey, do we help them, build a little bit more of the end-to-end solution if they need a lot of help, if that's what it takes to make them successful.
Would the unit economic, like, we don't have to use your company as an example. Like, obviously, what's the unit economics in like software like this, or like in the chips? Because I feel like chips is partially hardware, right? Like, although I feel like
it's definitely hardware. Yeah, I mean, so semiconductor businesses, and this business is really like they're not 90% gross margin businesses. Chips have slightly different margin profiles of companies, and if you build a really commoditized, really sort of basic semiconductor, you could have very, very low margins. And if you build something that's very unique, that's very powerful, that has a robust software ecosystem around it, you can enjoy far higher margins. But like, I think those margins would be, again, not talking about this one, like in the 40 to 70% range, not like the 80 to 90% range very often.
Then why don't you invest in the 90% profit margin companies?
We do. I think there's a whole bunch of opportunities, as I said, around sort of edge models, model deployment, model updating, and the applications on top. But it's just like, where is the market right now? And whether we're in edge or whether we're in data center, it's easier to study data center because I think we're a little further along. Like, who's made money in data center? Well, the chip vendors have made a lot of money in the data center. Well, the cloud infrastructure guys have made a lot of money it's unclear how many other people have actually made money. A lot of these foundation model companies, the jury's still out as to when they will turn gross margin positive. I think I'm very optimistic that they can sort of tune that dial when they're ready. But in terms of current data, it may be that the foundation model companies are losing data. And then you have a few applications that are starting to make money. Some of them are very efficient in this new world. They don't need that many employees to generate a tremendous amount of revenue. There's risks at the application layer in terms of what's enduring versus what the model companies might be able to do over time. But the point is, like, it starts like most of these sort of tech waves, they start at the bottom. Like that's where the money and profit center is going to be first, and it gradually moves up over time. And at first, you see these sort of apps that tend to sort of tactically sort of take advantage of the developments. And then a couple years after these things come out, you see these truly like native applications that sort of understand the impact of really what this technology means and build something novel. And it's sort of like, if you look at the iPhone, like how interesting were the apps for the first couple of years? Like there was no Uber, there's no there weren't these sort of transformative experiences, get like photos and like the email and a lot of the same things. So it took a couple years for those really, really interesting apps to emerge. And, I think we're about to be at this moment now. Now we have these conversations about whether things will be apps or agents or, how will they manifest themselves?
Wow, totally. What are something that you would never invest in this category?
Never invest.
Never, but like just like generally.
So I'd say we're an early stage venture capital firm at Wing, and some of these foundation model companies want $100 million plus financings out of the gate, and I'd say it's hard for an early stage venture capital model and to sort of figure out how to connect with an opportunity like that. And so I think some people will have phenomenal returns, whether that's called, whether that is venture capital or a different type of investing. I'm not quite sure. So those will be really hard. We tend to shy away from consumer. That's just not our background. There's a lot of things that are sort of blending these sort of prosumer to enterprise experiences.
I mean, like in the edge space or in the AI space, of course.
Yeah. Well, I mean, a lot of these consumer, it's something that's completely consumer AI is probably going to be less of a fit for us. I think there's some things that are sort of truly low margin, hardware devices. Whether those are like cameras or pins or other sorts of things, we don't spend that much time there. And so I think we touch a little bit of hardware at the semiconductor level, but we're like much more interested in the invest far more frequently in the sort of software infrastructure layers and the application layers, particularly sort of with an orientation towards enterprise use cases. Those are the things that excite us the most.
Totally. Okay, so let's talk about domain-specific models. Let's start with I feel like for domain-specific models, is it actually different model? Because constantly I'm seeing the ChatGPT for fintech, ChatGPT for lawyers, or like ChatGPT for something. So that's kind of like a thing on its own. But what is domain-specific models? Are they actually different?
Again, it's an area to me that the definitions are blurry, and can you sort of tune your way or prune your way from some large model to something that's narrower? To me, in its purest form, a domain-specific model is, in this conversation, will be sort of like a foundation model that's built around a specific domain. And so that domain might be security, it might be a subset of security, it might be data lineage, it might be part of biology, it might be small molecules, it might be an aspect of speech. And the thing about these models is that they're just sort of really focused on sort of doing one thing really well, and they're not sort of littered with other artifacts that might sort of create some problems. Like the internet is a wonderful thing. There's some truthful things on the internet. There's some questionable things on the internet. And so by sort of building a domain-specific model, you sort of don't have to deal with any of that other information type. And I think there's a lot of opportunities as a result. If you're designing a drug to cure a disease, if you're trying to solve a particular security problem, these are things that just you need to get right. The cost of being wrong can be high. And I think short to medium term, at least, who knows long term, I think we're going to see very successful companies that adopt this domain specific model strategy to build something a little bit smaller, maybe that doesn't cost $100 million to make, that is just really focused on helping you with one particular use case.
Why don't we talk about what does building a model means? Like, so obviously, like, why is it so expensive? So obviously there's like the GPU cost, and then there is a bunch of like human intensive, like people labeling stuff, or like what's the cost breakdown of building a model kind of look like?
It's a very hard question to answer, and the answer is going to be like unsatisfying. It depends. If you have a lot of human labelers, that could be very expensive. I think the beauty of a lot of these systems is they don't require much, if any of that. When we look at models, when we look at opportunities, we really study the data. Like, how known are these answers? How subjective versus objective are they? Are there really good ways or test harnesses to verify something? If you're designing a chip, really interesting ways to like verify functionality. If you're designing a piece of software, like pretty decent ways to verify software. If like you're picking a color palette for someone, like, I don't know, like that's much more subjective. You might need to, like collect feedback or something like that. So I think there's some spaces that are just sort of more amenable to having real ground truth data. Sometimes it's accessible, sometimes it's not. And then you need a strategy to potentially generate, more of this data. And so I do think the compute cost is a driving factor. And what I would say is that if you don't have to sort of take the entire world's data, just sort of, again, objectively, you can look at a much narrower slice of data. So you may need a much smaller slice of GPUs and everything else to build a model around it. All the medical literature on oncology, let's say, that's just very small compared to the entire internet. So it's just easier and smaller to start.
Okay, so I don't know if you want to talk about this, but like let's say if you and I are building a drug discovery model, what's our day one kind of look like? And yeah, how does that?
Yeah, I mean, so interestingly, like a lot of the success pattern that I've seen isn't necessarily just people building models to start day one. Sometimes it's building a company and building a model along the way. And so a couple examples in these spaces, I work with a cybersecurity company called Cyberhaven. They're in this sort of data loss protection or DSPM category. They help you sort of trace data if it's going somewhere it shouldn't or leaving your organization. And a lot of their initial products were sort of in this vein. And along the way, they said, hey, like we actually can see some pretty interesting sort of data flows. And they built what's called a large lineage model. And so for them, the movement of data is the piece of information that they're sort of training on. And can we understand what like a good or normal movement looks like in a weird or concerning data movement looks like? In the case of biology, a lot of these new drugs are around small molecules. And so understanding, sometimes collecting the space of data in biology is really hard. Like, what are all these things doing? And like, how can we assemble them? And so, it's not day one, I want to build a model, but like maybe I'm building a data generation platform that's really unique and 100 times faster and cheaper to generate the data that I'm now going to put in to this model to help with a particular type of drug discovery. And so these are sort of examples of how one might add a domain-specific model into your business over time.
Okay, so I was taking notes that you were saying like so there is like normal movements and then concerning data movements. Since like if you have no data at the beginning, how do you know if what's like normal, what's not normal?
I mean, you don't. I mean, a large enterprise, like, it's a very interesting question, and there's two ways to answer it. Like, a large enterprise, like, already has data. Like, they already have some sort of solution. You know, they're not a 100,000 employee company that just has sort of no security, no logs, nothing. And so, like, it might not be in your system, but like there are traces of what normal is. And then, you know, there's a lot of similarities how different businesses behave. You know, a regulated bank, you know, will have certain access patterns that are similar to other regulated banks for the most part. And, you know, fast moving tech companies will have, you know, maybe different patterns. And so there's an element of what something out of the box can just do, that's sort of sensible rules and understanding that's tuned for your particular use case. And then what are those times and areas where you really need to appreciate and understand and capture the nuance of what makes that company special. And I think a lot of AI and generative AI companies, you know, work this way. Another company that actually has a domain-specific model for speech called DeepGram, you know, that what they do is they build sort of speech to text. And a lot of what they do is they start out, they have speech to text is pretty good, but then they take some of your own company's data, and through, you know, looking at some of that company data, they can start to pick up all this weird jargon, or what are the acronyms or abbreviations that you use that the rest of the world doesn't use, and then they can, you know, make sure that they capture those things equally well, right? And so that can't happen at t=0, but it can happen very quickly. You know, like once they have access to a little bit of your data. And this is the way I think a lot of AI systems work. They need to work for a general case initially, and just sort of get better and better and more tuned as they go.
I have a question in this domain, right? So let's say like I'm building a fintech app, and then not I'm building a fintech app. Like, okay, I'm building foundation model for like hedge funds. And then, but like there is like 5 other company, let's say like a BlackRock or something, building this in-house or whatever. Like, so I'm not saying BlackRock, but like I'm just saying like a company that's like really big in the hedge fund world, and then they're just building this in-house because they have all the data, right? Like, and then as a startup, like, am I supposed to spend all the money into acquiring these data, or like, if we're building a small foundation domain expertise model, like, how do we spend money, and then how do we keep it like kind of like profitable, because it sounds like it's going to be very.
Yeah, I mean, hedge funds are a tricky one, and you sort of always ask yourself this question: if you build something new for finance, isn't the best thing to just sort of like start your own hedge fund versus like arm all other hedge funds? And you know, those guys have a lot of money, of course, but I think you're really looking for these platform-oriented opportunities. And so I come back to a lot of the examples I highlighted. Like, it doesn't make sense for the average technology company to build like a security-specific model. It doesn't make sense for like the average application company to build a voice-specific model. These things should just be sort of built and tuned by, you know, one entity and leveraged across. I think you're going to see there are plenty of companies that are innovating in the finance space that can help you amass different data sets. Of course, like the hedge funds are, you know, always going to have some sort of proprietary either data or perspective, and they're going to not want to share that with the rest of the world, and they're going to want to blend that with the provider who, you know, makes this real. But at the same time, all of the DevOps, all of the, you know, the things that go into creating the model, to hosting, to making it easy for people to interact with, it's just, you know, like that's not the core competency of most fintechs and most hedge funds, let's say. And so I think some will build and some will buy. And I think there'll be sort of great opportunity for both. You touch on, incidentally, like something I'll just mention briefly that maybe you thought about, maybe you didn't. Most generative AI is not yet very good for time series. So there are classes of things that generative AI is sort of quite good at. And there's a lot of information about sort of making creative text, painting a picture. Time series predictions is not an area I would say, you know, like I wouldn't put in the solve problem bucket.
What's time series predictions? What does that mean?
Anything with time, like when is there going to be like the next downtime? Like which stock should you trade and like go up? There's reasons for this, but I would say we're earlier on just sort of dealing with time series data in the context of generative AI. So I think that's a really interesting area for me, and we're starting to work with some companies in that space, but that it's surprisingly less solved than you might think, given all these amazing, powerful things that can be done with generative AI today.
So like, what's okay, can you give us some example of like the time series data? I mean, like what?
Yeah, I mean, so like computer logs of like failures in memory, stock ticker prices, and like when's it going to go up and go down, weather predictions of what's going to happen. Weather prediction.
Weather, like the weather. Why does that even matter for the stocks?
No, it doesn't. Like, I'm just giving you random examples.
Okay.
Or maybe it does. Like maybe, when there's a rain, like it means a certain thing. But all of these time series oriented data things, if you need to make a prediction, like you might need to move around emergency resources based on weather predictions. You might want to stock your store based on differently, like when it's going to be cold in the example of weather. In the example of computer logs, you might want to predict a type of failure or something like this. And obviously in the stock market, you want to sort of predict stock movement prices that you can trade against. And I would say if you sort of roll back the clock, like a lot of AI is not this generative AI. And most things that are doing time series predictions are not using anything that I would sort of call generative AI today. They're using sort of other AI-powered techniques for time series predictions. And I think there's a real opportunity to take foundation models and apply it more towards time series predictions. And people who have like use cases and opportunities around that, I think are really interesting right now.
Wow, that's really interesting. So who can predict this? Like, what are some solutions for that? Is there any solutions, or like, I mean, there's a weather reports. I'm sure there's some sort of prediction, right?
Yeah, but I mean, again, I don't think they're using generative AI. So I think there'll be a new crop of infrastructure companies, and we've seen some, none of whom I think are public that we can talk too much about yet, but like that are trying to bring foundation model technology towards time series data, and I think it'll be really exciting. And if you think about just how much value AI has created and where it's used the most in the world, a lot of the current things, not the new Gen AI thing, I mean, like a lot of them are sort of a little bit more time series oriented.
Wow, that's so interesting. Good to know. I mean, someone have to create these like time related things. Okay, so from an investment perspective, what are something that you would invest in this domain?
In domain specific?
Yeah,
or
domain
time
models.
I'm just looking for teams that sort of have a unique perspective on a space, likely that they have lived it and they understand, enough about foundation models to explain to me, how they're going to apply it. And I think it could wind up in very long tail areas, or it could wind up in more mainstream areas. There's a lot going on in legal, it turns out at this moment with generative AI, will it be big models? Will it be domain specific models? Will it be, for agreements or for patents? There's always this question of like, how do you slice things down? What's too narrow? What's too broad? Where's the sweet spot? And so I think we'll see a lot of people that are building solutions for narrower, interesting verticals. And then we'll see people that might want to build them for more generic things. And in some cases, things might be generic enough where, is it a domain specific model that'll solve automating my sales reps, or will it be, the broader model that does that? Something like code is kind of interesting because, like is code going to be sort of its own branch of model, or is it going to be, like a more generic model that happens to also do code? And so code is an interesting one because it's sort of like it's crossed the chasm to where it's almost thought of as not a domain specific model, even though sometimes it sort of is.
I have a question for you. So I think like, okay, since you brought up like the legal side of things, so like there's two set of like AI I've seen. So one part is like um automating the lawyers like non-legal task. And then there is the chat GPT for lawyers companies, right? So I think the chat GPT for lawyer companies are the one that building domain specific models. But in this category, there's obviously like the Harvey or something like, but there's also a bunch of startups that are doing um like that equivalent or like domain specific things for corporate lawyers or in-house legal or um uh like business contract writing or like some other stuff, right? um I'm sure you've seen a lot of those, like probably a lot more than me, but like I wonder what's your like kind of general thoughts on this category and like
Sure,
who's going to be
sure.
the
Oh, I think there's going to be a lot of winners in these
It's just
categories.
gonna be like, but
But
if there's a lot of winners, are they gonna be like so small companies? Like, are they?
no, well, I mean, I guess the lens through which I'll unpack it is a business model lens, right? And I think there'll be sort of opportunities and challenges with each of these models. And so, for in the case of lawyers currently bill by the hour. And so, if you give them technology that makes them more productive, let's say, how do they sort of charge for that or recoup that? Do they have to sort of disrupt their own business model and now say we can be more efficient and charge less? It's kind of hard to disrupt yourself. And so it's challenging, right? Like when you say, I'm going to take away half your work, and you're going to make half as much money next year. Do you want to buy my product? That's a tough pill to swallow if that's actually what you're asking. It's not quite how it works today. Whereas, like let's say, I'll pick up on this like patent filing case. You usually sort of like outsource a part of patent generation. It's like, they're very sort of standardized rates. And this notion of like work that you already outsource in chunks is a really interesting one. Would you just pay to have an AI do that or an AI powered service to do that? And could you sort of compress that market? It's an interesting market because there's not, probably enough people with the right skills to create patents. Sometimes it can take too long. And so would you want to like compress that market and say, instead of whatever it is, $10,000 to help me with this patent, it's going to be 3,000 and it's going to be, 80% AI and a little pixie dust of human expert on top. And so I think we're going to see a lot of different business models. Some are going to be offering you the core tech. Some are going to be charging you on a usage basis. And a couple are going to be charging on like outcome basis or virtual worker basis. And so this is where it goes back to this original, thesis I have, where it's not about like, can you build these things for legal? I think the answer is yes. It's what's the right packaging and business model that helps you most unlock the opportunity. And to your point, we've seen people attacking it from multiple different sides.
Love that. But is there something that you find really interesting in the space that's doing something unique?
In the space of legal?
Yeah, since we're chatting about it. Or if you don't spend a lot of time in the legal space, which
I don't spend that much time. I don't spend that much time in legal, to tell you the truth. I think a lot of what's going on is the interesting thing, the interesting observation that I have is that if you would have profiled venture capitalists 5 years ago and asked them like, hey, should we invest in like legal tech? You would have gotten like 99% no. As the answer. And they're hard to sell to. They have certain regulations. They're sort of slow moving. They can be partnerships. There's a lot of reasons why selling it to lawyers is not the most fun thing in the world. There have been a few businesses that have been built of substance, but not many. And so it's very interesting that we're now in this moment where a lot more people are open to investing in software for lawyers. And I think it's sort of this sort of labor spend services attack. And I think a big question, if you think about the power of Gen AI and going into all these enterprise areas, is how much of it will be replacement software. It's like, I'm going to replace some core piece of software that you have, whatever it is, spreadsheet, CRM, some workflow system. And how much of it is going to be like replacing this human spend, this labor market, this service market. And you could sort of argue, if you are doing both, let's say, that the opportunity in front of you is, maybe an order of magnitude bigger than just if you were doing the software. And so that's a dynamic that I think that's going on in legal, and I think it's going on more broadly. And it'll be really interesting to see how much it plays out, and how much are we like displacing software budgets versus human budgets with some of these things.
What are an area that you spend most time on in this domain-specific model situation?
So security is an interesting area. Testing is an area I'm spending more time in. I kind of think that code gen is going to be crowded, and there's a lot of very large players that are doing things just for regularly writing code. Contrarily, and weirdly, we still haven't solved testing, which to me seems like an easier problem. Like, you can't tell, you're still having humans write the test. The AIs can't tell, in some cases, you can't always tell whether there's like a regression yet we can write all this new code. And so testing is an area that's really interesting. Security is another area that's really interesting that touches both code and non-code. Security, you can't really get it wrong. You can't say, hey, this is going to get it right 99% of the time, go have fun. Like, that won't work well in security. So just from a risk reward perspective, you need different approaches to think about code security. And then, applying domain-specific models to different facets of security, I think we'll see more of over time.
Why don't we start with the testing part? So, I've seen a lot of AI testing thing, but I don't know if they're domain specific models. I thought it was just I did not know either.
The answer is there's everything and anything in between, and who knows what the right answer will be. Maybe you can just give an agent and a big foundation model the right powers. The question there would be, is some generic tool gonna solve your problem, or would the right approach be something that knows a lot about code, a lot about testing, that's going to plug into all of your GitHub code, it's going to plug into all of your testing frameworks, it's going to read all of the PRDs and sort of product specification docs in your org to create a better experience? And are we going to start from a big model, or are we going to start from a small model? And the answer is, I don't know. Maybe it's one, maybe it's both. But I think that's an area that's really ripe for different types of new solutions.
Like what?
I think people hate writing tests. There's entire departments that, that's their job. But I think for many people, coming up with the tests, these tests can be brittle. You have to create new tests as you add new functionality. And so I think we're going to see a lot of solutions that try to take on closer to the full life cycle of creating the test, making sure, adapting it if it's becoming brittle or breaking for some reason, and adding more tests as you build more functionality. And candidly, I think it's an area where if you had to bet, ask me, are we going to remove a software engineer from a company and no longer have a software engineer, or remove whatever you want to call it, a test engineer, a QA engineer? I think it's far more tractable short to medium term to say I'm going to remove a tester. End to end, right? And we're always going to get leverage and efficiency in every area. But it's an area where I could really see, for certain classes of testing, we could get out of the business of needing very sort of human capital intensive approaches to sort of creating and maintaining tests.
How much money does a software company would spend on QA testing?
I mean, the market broadly, it's billions and billions of dollars are spent on testing, and the result of having bad testing or letting things slip through the cracks is also billions and billions of dollars. So it's a large market. I would say the market is a little more fragmented than maybe some other types of markets, and it also has this element of, in some cases, outsourced human services. And some places are contracting out to people that they might have test frameworks, but they also have people that are helping you manage those things.
What's the biggest challenge in this thing? I mean, I have a great deal of flows in this space, which I'm non-technical, so I don't really know what's like biggest challenge, because everyone say everything is the biggest challenge.
There are a lot of things that you have to hook together in a testing experience to really be able to go in and just say, day one, you have a product, maybe it's a consumer product, maybe it's an enterprise product. What is the T=0 experience, the beginning experience, to understand this product and to figure out where to begin? I think that's kind of hard. I think the challenge of how do we keep track of things and slightly update things, that feels a little easier. There might be a lot of product work in that. I think the technically hardest thing is how do you start? And maybe some of that is as simple as, if you're already a big company, we're going to take all your tests and start with your existing tests. But how do you start with that sort of 90% coverage experience day one, whatever it is, using domain-specific models, broad models, agents, whatever it takes. And my intuition is you're going to have to string a lot of things together to make this work right at the beginning.
Very cool. Okay, so another thing you mentioned is code generation is crowded. So do you mean cognition, like Devin or something, that's code generation?
Yeah, there's a lot of venture-backed companies that have now raised a lot of money, and there are a lot of publicly traded companies that have an offering here. And so I think that creates challenges and opportunities in terms of what do you expect from these sort of well-funded startups and the incumbents. And there's always room for more. But is the competition going to be fought at the model level? Is it going to be fought at the agent level? Is it going to be fought at the user experience level? And I think we'll sort of see these things play out over time. I think it's going to be challenging for small companies to compete in that domain on the model level. I'm optimistic that they may be able to do it on the agents or the user experience level.
Why are so many companies spending so much money on this? So obviously, I think people always want to. Another question is okay, so in the future, are we gonna just write in English and then an app just build itself, or is that just never gonna happen?
Well, this is a fun conversation. I don't know. A couple years ago, you might have said, hey, we really need a designer and a product person and some sort of software architect in a room to be able to make a decision about how something worked. And then big data came along, and they're oh, okay, should we also think about data? And then we put through another person, a data scientist, maybe into the room to think about the data flywheels. And now we have this question of what does software engineering in the future look like? I have no idea. I think it's fully possible that for simple applications, you might have the experience you described, where someone that is a product manager who's sort of savvy enough can just dialogue with something in plain English and wind up with a small basic product. Someone who is not a product manager, will have to be guided a bit more through a process to ask you about these edge cases and everything else, and still, get a product. And more broadly, it'll be interesting to see as the early returns of all this data from the code gen, who's getting the biggest improvements? Is it the sort of entry level software engineers or the senior systems architects? And what will it mean for the nature of development orgs? I'm very bullish that software engineering is still going to be a good job, and we're just going to write a lot more software to do a lot more things as opposed to automate everything. And so I think software engineering will still be a very, very good job. What will that team look like? Will it sort of shift and sort of have less entry level people, ratioed to senior people? I think
but if you have no entry level people, how do you get to senior people?
That's a great question. I'm
really sorry about this question.
Yeah. So I don't think you can. I don't think you can have none. I don't think you will have none. And maybe the job description is everyone levels up, and the nature of being a software engineer will also be coordinating some agentic work around you, right? And so like every software engineer will be responsible for a certain number of agentic flows, and there'll be junior people doing that and more senior people doing that. You're right. Structurally, if you sort of said, hey, we no longer need any junior people, it's sort of going to create this sort of self-fulfilling problem where where things would get into trouble. So I don't think that's a realistic outcome.
Okay. So I want to be mindful of time. So let's wrap up with like a 1 minute fire round for you.
Okay.
What's your favorite book?
My favorite book. Just had some lengthy conversations about Thinking Fast and Slow by Daniel Kahneman.
Surprised, but classic. Who made the biggest impact in your career?
Biggest impact on my career? It's a great question. I think my parents, just in terms of like shaping my views on sort of technology and work.
Who would you invite to your dinner party?
Right now, who would I invite to my dinner party? I mean, Elon's in the news a lot, so I think he'd be pretty fun to have dinner with.
Where can we find you outside of work?
Doing a lot of stuff with the kids, maybe trying to get a workout in the garage, and that's about it right now.
Amazing.
Maybe a whiskey tasting.
Oh, whiskey tasting and the kids. I know that
separately. That one without the kids. Yeah.
Okay. Well, Jake, thank you so much for coming on the show today. It was such a fun conversation.
My pleasure. Thank you so much, Grace, for having me.
Let me quickly end stream.